Why don't you tell us a little bit about yourself?
Sure. My name is Craig Cornelius. I've been involved in internationalization for almost 17 years in the I-18N group here at Google. And I've been privileged to work with some Indigenous communities, starting with a chance contact with a friend from the Cherokee Nation, and that's led to meeting many people in the translation, localization, and internationalization field who are not members of the big language communities. That's enough.
Okay, so that's Craig. My name is Tex, and I've been working in internationalization 3 decades. So for a long time, I'm a consultant, and I've helped many companies with bringing their products to market on the internet, on the development side. I'm also a contributor to Translation Commons. Translation Commons is also a community of volunteers, and they are collaborating with Indigenous communities to bridge the digital gap. And that's part of where this keyboard project comes from that we're going to talk about. We also provide global conferences. We're creating guidelines for digitization. We provide training, especially hands-on training, and practical experience to help people with digitization. So today we're going to discuss designing keyboards and lessons learned as part of this project. And just so you know, here's some of the results of this project, where we have volunteers, largely with Craig's guidance and a few others, where we can train people and have them create keyboards, and we provide training and documentation on how to do that. And here are some of the keyboards that we've already created. You can see some of the examples of the characters that are being generated. Any questions so far? Questions about the languages? Okay. So just to orient you, this is what we're going to cover today. We want to talk about why language digitization is important. We're going to talk about some of the challenges due to the diversity of written languages. And then we're going to get into a little bit the techniques for keyboard creation. We're not going to get super technical. We tried to keep it abstract while at the same time making it something where you understand what kinds of solutions there are in order to create keyboards. And then we'll spend a couple minutes just on the futures for keyboard creation. Is that okay with everyone? Okay. Everyone here seems happy. If you're on the internet, feel free to send a chat to Amy. Make sure we're on track for you. All right. I know this is a group that travels. You may have come from another country. You may have been visiting different places. And I want you to imagine that you're somewhere and you don't speak the language, and something happens. Maybe you're here in a room like this. All of a sudden, people's phones are beeping. They're looking down. They're getting messages. They're excited. Maybe it's good news. Maybe they're panicking. But you don't speak the language. You're not getting those messages, or if you're getting those messages, you don't understand them. What's that? How are you going to get information? How are you going to know what to do? And, you know, boy, if you listen to the news today, between earthquakes, fires, crime, all sorts of emergencies, but imagine you're in a place where you can't get answers. I've had that happen several times on trips, and it's fairly uncomfortable. You don't know what to do. Maybe people are being told to go to high ground. Maybe they're being told to go to the local school. Whatever information they're getting in some kind of an emergency, you don't have access to it. So this is what it's like for many communities where there's a pandemic, there's an earthquake, people around them are getting information, but nobody can type the information up to give them either a translation in their local language or to have somebody who speaks their language type it and print it out and give them information or send them messages. That's one of the fundamental issues. So there are 7,000 languages today. 3,000 will be extinct by 2100. This represents a loss for those communities, their cultural identity and heritage. They can't pass it along easily, only orally. We're losing out on diverse and alternative viewpoints. To some extent, for people who study languages, we're losing out on linguistic diversity and the different ways the brain works and accommodates information. And we're losing a lot of knowledge. Could be medicinal, agricultural, practical. And, you know, often when I hear that, my background is academic science and physics. And I tend to think, what can another culture offer that, you know, science hasn't spanned? But there's a lot of information, especially regional. And we hear this more and more today, where there's a community that understands the local plants, which ones are poisonous, which ones are medicinal, the local animals, the local terrain, what's happening in terms of the geology of the area that is affecting the community and affecting the future of the community. This kind of information is very local. It's not something that is necessarily understood by the broader academic knowledge. So, and of course, most importantly is social inclusion. How do you defend yourself? How do you represent your point of view? If you can't tell people they don't understand your language, maybe you can't communicate in their language, how do you share your opinions, your needs, and so forth? So you become marginalized. People make decisions for you, about you, without your input. So one of the solutions, we need a lot, but one of the first solutions is to be able to have text entry, to be able to type a language so that it can be communicated, so it can be studied, so and so forth. So you see here a list of the benefits, some of that are kind of indicated by talking about the problem statement, but it helps with maintaining heritage, capturing history and traditions. It allows you to communicate across distances. This is something probably all of you do with your families and friends as you move around, right? You can type a message and it goes and it keeps you connected. But if you can't type in your language with people that share that language, then you don't have that. And of course, it expands teaching, and you can share the culture to the world. You can also better understand other cultures, and you can get representation and self-determination for your community. Make sense? So we think this is important, and that's part of the reason we want to develop keyboards. So the way this works is you go to translationcommons.org, a community can find a page there where they can request a keyboard. It's run by volunteers. We take a look at the request and then we have some information we try to understand. Is this a completely new language? Is it a dialect of another language? Is it a language, but it needs to be in a different writing system? You know, some languages are written in Latin characters or Cyrillic characters or Arabic characters. They can have more than one way to write their language, but not everyone can read all three scripts. So they need something that works in the script they're familiar with. So, and sometimes we get requests for a keyboard that for various reasons doesn't work. It exists, but it doesn't work so well, and they want to have a modification or maybe an enhancement that will support their dialect or language. So we ask these questions, we try to identify the character set and whether there's some other information that's a part of language digitization. that has been defined? Does the language have a language code, an ISO language code? Is there a script code, or is this a completely undefined script? Does the characters have a Unicode encoding, right? Or a font? And what are the writing practices? So we have to ask all of these questions, and we try to work, if the language is standardized already, we try to work within that space. If it's not, then maybe we have to set in motion, one, to understand the writing system, but also maybe we can set in motion getting the language standardized in some way. Create a font, bring a proposal to Unicode, and so forth, right? These are all the basics of language digitization. We can also attempt to create a keyboard, even though it's not yet standardized, to have a prototype or a way to work within the language. And that's a whole different ball of wax, but maybe if you have questions about that at the end. So what are our goals? We want to create a keyboard that represents the language. It should represent all of the characters used in that language. We want it to be used in a way that it's consistent with orthography. In other words, the way you would write, it should represent that. You don't want to have to type in ways that it's not the way you think about writing, right, or spelling. Sometimes we take a look at whether there's prior technology experience. So in Africa, many people speak French. There's French keyboards around. Maybe we want to build on a French keyboard layout. If that makes sense, maybe there's some other technology that makes sense. And also it needs to be supported by currently available technology. We don't want to design something that will work someday in the future, right? Seems obvious. So we want to be standards compliant. It should be comfortable to use for long periods, right? We have to think about how the keyboard should be laid out. And it should be efficient for generating text, right? So, because you could take 10 key presses to generate a character. That's not efficient. So, in terms of being complete, here are all of the things we might think about. You want to support native letters. You want to have room for digits, accent characters, tone marks, punctuation, arithmetic operators, various symbols like currency or copyright may be needed. Some of the keys may be needed by applications. So some markets are bilingual, or maybe if your script is completely different from Latin letters, but in order to use programs, you may need to still have access to Latin letters, so the keyboard has to be bilingual. You may need to support some functions like the keyboard controls. Those take up some of the keys. And for some things, you may need to support system level controls. We're going to talk about bidirectional languages for a minute. And for those where you want to set the direction of a text box, you need to have a system control for doing that. That may take up some space. And as I mentioned, you may need room for additional characters to support the local dominant language, or for popular loan words. So even here, San Jose has an accented E in it officially. So if you thought English was A through Z only, and you held to that, you'd be missing out typing that. You couldn't even type your resume, right? Right, that's why you couldn't type it. So, so here are some examples. I won't belabor this, but you see Cyrillic. There's about 55 characters there, Greek characters, and that's without the punctuation and diacritics and so forth. Now, for diacritics, I want you to think a little bit about designing your keyboard. There can be many accent marks and tone marks. And you see some examples here, and they can be applied to many letters. So for Latin languages, A, E, I, O, U all have some accents. And you can easily come up with, I'm showing 6 or 7 here. Multiply that by the 5 vowels, that's another 35 letters, times 2 for upper and lower case. So besides the 50 or 60 letters I showed on some of these scripts, you're now adding another 70 variations, or up to 130, and that's without digits and punctuation and so forth. So also some letters in some languages have more than one diacritic or tone mark. So I'm showing a few letters here that have a letter, an accent above and an accent below. There are some that might even have 2 above or more. So it can get interesting. But the point is that having these diacritics greatly multiplies the number of characters you might need to support. And another question might be, do I support each of these characters with the diacritic and tone mark? Should each one get its own key, right? You hit a key and it's going to generate A with an accent above and a dot below. And then the next one for another character. Maybe. Or I could support a base letter, like a letter A, and a separate accent mark. And so I would type A and an accent, and it gets composed into A with an accent. But then I still have to wonder, is it A with an accent, or should I do accent and then A? And there are systems that can work either way. And then if, as you see here, this character has 2 marks, should the order matter, or maybe not? So as we get into keyboard design, we have to start to understand both the requirements of the language and whether we have to save space, save the number of keys we're going to use, or we can generate whole characters, and which is more efficient. Okay. So here are some script examples, some other script examples. This with a keyboard. This is Cherokee. And we're not going to show all the variations with, shift and shifted and so forth. Here's a Thai keyboard. And now, in Translation Commons, we're developing mostly virtual keyboards, which are used on mobile devices. We do have some variations for essentially a virtual keyboard on a desktop. But here you can see one of the keyboards for Texin Lakum, and you see the base layer and the shifted layer. Here's Chakma and Elfdalian. Okay. Now, some languages are bidirectional, as we've mentioned. I see here Hebrew and Arabic. The fact that the characters go right to left or left to right, not necessarily an issue for the keyboard. That can be handled by the software that's accepting the characters by your writing application. We build off of Unicode. Unicode uses what's called logical ordering. You type as you would think to spell the text. It's in that order. So if I type Aleph, Bet, Gimel, 3 Hebrew letters, then I type 1, 2, 3, and 1, 2, 3 is now going to go left to right, not right to left. That's the logical ordering. There were systems before Unicode, I used to work with some terminals, where you typed visually, where if you wanted ABC 1, 2, 3, or Aleph, Bet, Gimel 1, 2, 3, you would have to think, where did I want to put this character, and type it in that order, not how I would think to spell it or write it out, and that would place it. So it's important to know this is the way we build, and the expectation today is that all of the characters work logically. The more interesting thing, and this affects the keyboard design, is that characters can change shape depending on where they're positioned in a word. The other thing that you have to think about, well, two other things. One is you may have system controls to set the overall direction. Do I want to start the page going right to left, or do I want to start it left to right? And maybe when I get to some right to left text, then the text will change. But that makes a big difference to the layout. And sometimes where there's ambiguity, there are control codes that you can enter. And so all of these are things that may apply to your keyboard. Just to give you some examples, here are pairs of Hebrew characters. And if you're going, so let's go left to right. The first right to left. The first character on the right is the way the letter is written. And then the next letter, that's the same letter, but as it appears at the end of a word. And then the same thing for the rest of the pairs. As you go across, there's a base letter, and then at the final position of a word, it changes the way it's written. Arabic characters have 4 shapes. So, and you see this is one letter here, where if you're going, left to right, you see the final form, the word the letter at the end of a word, the letter as presented in the middle of a word, or the letter as it starts at the beginning of a word. And then if you have the letter by itself, that's what we're showing you there. So what does it mean for a keyboard? Well, should the keyboard have just one character and let the software application figure out what it should look like? Or should each character be represented by a different key or key combination? And it depends. It may depend on how it was done before. Sometimes we look at typewriters and other older systems. So that gives you a little introduction, but things get more complex. There are scripts that are change their rendering as you type. And so I'll give you one example here from Hindi. It also applies to other languages that work like this. This is the word Perti. I'm probably not going to pronounce it right. So, but here are the letters that you would type. The first is a letter that is called Pa. And then you would type a long U, that's kind of an accent mark. But follow along with this on the right. You type the letter P, and you can see the character next to it, how it looks. Then you type the U sound, and that vowel goes underneath the P. Then you type the R, it goes to the right. Then you type the Virama, and that goes again underneath. Then we type the T, that goes, let me see, I have that right, goes above. Now, we type the final I sound, that's a vowel, but the whole string kind of changes. And that final vowel goes before the previous 2 characters. So we have a number of scripts where actually the characters are reshaping the entire word. So we want to be able to address that. And that's part of where you have to think about what's the orthography, how is the word spelled, how do people think about it, and then what kind of reshaping happens. Should that happen in the application? Does it happen in the font? Where does that occur? Does that make sense? And when we design the keyboard, we want to understand these things. And so there are keyboards for Devanagari, which is used to write Hindi. So that's a really brief, quick survey. Let's talk a little bit about what's involved in creating a keyboard. And for that, Craig is going to present. Were there any questions in between?
I'm wondering for Craig, can you please use mouse to point on the slides so our online speakers can see?
Sure.
you.
Also, Craig, I noticed that the room
Microphone.
is, you know, if you put the camera
1 minute.
on for the room, would they be able to see the speaker?
I don't know. Are
Several people have considered how to fix this, so we can see the speaker.
because we're on a holiday, our video tech support is not available. So that's my excuse anyway.
Or we could try to use my laptop to show, but we want to
No,
see
no,
all
no,
of
no. Let's move on. We're not that pretty.
Tex has given a good overview of some of the variations that we need to consider when we're setting up ways of inputting text for languages. And I want to emphasize that text is not the only way languages are represented. There are many languages that don't have writing systems already. But for those that do, it shouldn't be impossible for them to start using their languages on mobile devices. It shouldn't be impossible for them to start building their own documents and printing them, but they have to have a way of representing the characters in their writing systems. So these are several of the pieces that have to be there if we're going to use technology to actually create documents, create emails, create websites, and so on in these other languages and writing systems. The first thing that's important is that we have to have a coding standard for the letters and the characters. And the one that seems to be almost everywhere now is Unicode. It's not the only way of representing text, but it is the one that is in some sense one, especially since the advent of mobile devices in your pocket. Every mobile device here has the Unicode standard built into it. Before 2007, that was not necessarily the case. Your computer might use an encoding standard that basically had different numbers to represent the characters of some languages' characters than my computer did, and it didn't matter because I didn't need to send you text messages. But now, with the mobile devices that are available and integration of the internet across mobile and other kinds of devices, Unicode is about the only way to go if you want to be able to share text a lot with everybody. We also have to represent something about the identity of the languages and the identity of the writing system that's being used. So here's a few examples. SR and TA and FR are Serbian, Tamil, and French, 3 languages which are widely represented on the internet now. And 4-letter codes are used to represent the scripts. And in this case, LATM is, of course, the Latin letters. Cyrillic and Arabic are 3 of the other codes. But there are dozens of these writing system codes, and all of these are represented in various parts of the Unicode standard. But Serbian is an example of a language that about half the people in Serbia use the Latin letters, and many of them have accents or other characters that are not present in English. English is not the only language, of course, that uses Latin. And in fact, almost every other language that uses Latin has some sort of diacritic mark or marks that they use. But if you want to type Serbian for the other half of Serbia, they use the Cyrillic writing system. Are they interoperable? Well, to some extent, it is possible to transform one to the other, but not completely. But people need to be able to type in Cyrillic or in Latin when they're using Serbian, and also consider all the particular characters from those writing systems that they'll be using, plus all the diacritic marks. Also, a character code is just a series of bits, a number effectively that's stored in a file or stored in your computer. But there has to be something that will take that sequence of bits and turn it into a shape on your screen. What Tex was showing us on the previous slides about characters changing shapes as things are entered is actually being done by a font. A font is a piece of software that is actively looking at the characters in a buffer, in a sequence of characters, and saying, given these characters, what shape do I look up in my memory, in the font's memory, and present it there? So a font is actually doing the heavy lifting, in most cases, of what Tex was saying about the characters changing shape. The font knows that if a Beh character in Arabic is by itself, it will have one shape. If it's the beginning of a word, it will have the initial shape, etc. So the font which merits a whole talk by itself, is actually doing a lot of the heavy lifting here for the shaping of the dots on the screen that you actually appear. Most of us don't have to worry about that if we have a font for the writing system that we use very often. But many languages aren't used very widely. Many languages don't have fonts that are installed on their mobile devices yet because, honestly, manufacturers haven't chosen to put them on, or people haven't developed many of them. And of course, you need a display device. The display device that we're all used to with desktops and laptops are big monitors and screens, but little monitors, such as the one in your pocket, and other are coming in many sizes and shapes and resolutions now, and we have to consider all of those. When you're talking about text, you also have to worry about what kind of application are you talking about. There are apps where you can put text, and it won't be very smart about applying a font. It will just put the text out there and apply some standard font. Doesn't let you do this. Notepad and some other simple applications don't let you have a lot of flexibility. And then there are others like Microsoft Word or Google Docs or other applications that let you have a wide variety of styles, of fonts that can be applied. Different writing systems can be applied. Some of them have left to right controls for paragraphs and many more things. Where does it stop, or where is the boundary between the characters, the text, and the style that's applied to it? In most cases, the applications such as a text editing or a text presentation system like what you're seeing now does most of the work of applying styles to things. But all of these things have to be supported by basic representations of the characters down at the beginning, the bits and bytes for each individual character, in most cases Unicode standard. So as I mentioned, the fonts present and represent the shapes of the characters and the symbols. And that can include actually many multiple forms of a single character with different diacritic marks, and also in some cases where ligatures are involved. If you think about the simple case of the letter F followed by the letter I, in many fonts, the F and the I are joined so that the dot of the I is often in part of the end of the loop on the F. Not in every font, but that is something that the font is taking care of for you. You don't have to worry about that yourself. And if you don't like it, you can pick another font. But again, that's set at the application level. There are other things that are important too. There's a language called Thai Pake. It is a language of Myanmar and eastern part of India. And it is written with Myanmar characters, the same characters used in writing Burmese. But the people in the Thai Pake community like their characters to be written not as the Burmese people do, but in a different form, and they have big dots on them, on many of the characters, and they prefer that style. They will actually look at Myanmar characters without those dots and say, that's not my language. Even though the characters are there, the style indicates whether they can accept that and read it well. And this is not unique to Thai Pake. My friends in the Cherokee Nation, when I first met them 10 years ago, said that there were older people in the Cherokee Nation who were not used to more than one font for their writing system. Why? Because for 200 years, there was only one metal font that was being used for publishing all their books, a text, one form of that. And in the modern era where text started being represented in computers and where fonts became an art form for many of the Cherokee entrepreneurs, the older people would say, well, that's not my language. Even though the characters were the Cherokee alphabet or syllabary, they weren't recognized. So fonts and text are mixed in an interesting way. Of course, one of the biggest things about characters is there a font to represent them? And this little mug with the I and the piece of tofu there, the square, indicates a problem with characters. You can have all the characters you want in whatever encoding you want, but if there's no font there to present them on your device properly, then you'll get what is called tofu. And tofu is used in our world to indicate little boxes with no flavor inside. And that's kind of what it appears when there is no character representation that you can read. This is what people on their mobile devices often get into when, for example, their writing system has been added to the Unicode standard, but the manufacturers haven't added a font to represent that. And before a font is represented on a mobile device, nobody's going to build a keyboard for it that would produce tofu and nothing else. So there are stages of the rollout of language technology that have to be understood before someone can actually start using her writing system that's newly adopted into the Unicode standard. There are a few challenges in keyboard design, and Tex has touched briefly on them. We have to wonder, do people know how to read and write in any language? And then the second question is, do they know how to read and write in their own language? There are many communities that read and write in a dominant language. That's what's taught in schools, but they've never learned to type in their own language. Their parents may never have seen anything written in their language. And so there's an educational component here. Now, many people are trying to revive their own languages, make sure that the young people learning, they have to make a decision. Am I going to do it in a Latin script or a Cyrillic script or an Arabic script, depending on the part of the world they are in? Or am I going to use a traditional script, which may not be widely known, but might be part of the Unicode standard? There are people who are excited about using the traditional scripts to not only help them read and write in their language, but it gives an additional sense of identity for those communities. And Chakma, which was one of the languages on an earlier slide, is one of those where there are a few people who are bold innovators and tremendously strong promoters, not only of their language, but their writing system. And they have to work with their communities to develop educational systems, to develop groups that can read and write so they can put up signs, and so they can start generating books, children's books, and other documentation, which is really important. So these questions about who is using this and who could possibly be using your writing system and the technology that you use to create text in this, those people have to be considered. Text also mentioned briefly about some of the efficiencies and comforts that are required for this. I'm not going to read this whole list, but you all know that that typing is work. And if you have a language which has only a few characters, you might be able to get by with 2 fingers. In fact, many people used a system when I was learning how to type, and I learned how to type on a physical typewriter. When I was learning this in high school, it was unusual for boys to be learning typing in the 1960s, but I did. Many people use the HPRO system, hunt and peck the key and then rub out. So HPRO is hunt, peck, and rub out as you make the mistakes. And that's a very slow method. People get faster as they learn where the characters and the keys are. But things like the size of your hand and how do you have to stretch and where do you put the characters you're going to use most often become an important part of the design. The QWERTY layout that anybody who uses or writes in English is pretty familiar with is notably inefficient in terms of where the keys are placed. It was designed for a technology of the late 1800s where the mechanical interfaces weren't fast enough to keep up with people if the keys were placed in convenient positions. The strong keys ought to be on your index fingers and your middle fingers, not your pinkies. But they put some of the keys on your pinky to slow people down so it didn't mechanically jam. Is QWERTY obsolete? Well, of course. But is it ever going to go away? Probably not. But when we're starting a keyboard for a language that isn't represented, we should think about how we can best represent it so people can type it efficiently. We also have to think about the character frequency. How often do you type an A? A is on your pinky in the QWERTY keyboard. In French, it's even worse. It's on the A and the line above. How often do you use the A? All the time, at least in the languages I speak and write. But why is that there? Does it have to be if you're designing a keyboard for a language? And you want to make sure that people can indeed learn this easily. There's some considerations about learning it, though. Tex mentioned it. He mentioned the word virtual keyboard. We are not talking about actually designing, in the Translation Commons group, new physical keyboards that you will go to the store or that you will buy something and plug keycaps on top of your keyboard. We're talking about something which is virtual keyboard, because a virtual keyboard is actually the idea that the key you touch is somehow connected to the character that appears on the screen, but it isn't necessarily a one-to-one. When physical typewriters, as I learned on, were the case, it was one key and one shift or not shift to one thing on the screen, but virtual keyboards can be much more flexible. And indeed, virtual keyboards allow you to take your physical keyboard and type any language on it, as long as the computer knows that, oh, I'm in a mode where it says that particular key, say on the F, is not going to produce an F, but it's going to produce another character because of the setting of the physical keyboard has been changed. One disadvantage of virtual keyboards, however, is especially on soft keyboard devices, the physical contact, the physical feedback may not be there. On a physical keyboard, you're usually using two main layers, the base layer and a shifted layer. But very often people set up with more characters than those, create a numeric layer. And these are examples of layers on a mobile device. We don't need the 4 layers. Sometimes we don't want the 4 different rows on a mobile device because there is limited space on that. So mobile devices often have a base layer, a shift layer, and then a numeric and symbol layer. And this represents most of what people need to be able to type in the English and other Western languages pretty simply. Other layers can be added because it's all soft keyboards. The computer's drawing the layer, you touch a region, and somehow the computer figures out, oh, given the layer and the position you touch, that's the character that needs to be put on there. And so there can be as many layers as needed on a soft keyboard. You can simulate this on a physical keyboard as well, with the shift, the control, the alt, and all the possible combinations. There can be as many as 8 physical layers that are represented on a physical keyboard as well. Now, how does this work? Well, it's important to note that input isn't a key to a character. Input is actually a program. So the little box I have down there, and it happens to sort of look like an old IBM card, because I grew up in an era when I was actually physically typing on a key punch. But between the physical keyboard here, when you type a character here, there's a code that is sent to the computer. It says where on the physical keyboard it is, plus the information that's recorded on what other function keys, shift keys, etc., that are typed, goes into a program, and the program simply figures out what should I do that the person has made an event happen on that keyboard. And in a simple case, it looks it up and says, oh, that code is an A, which is represented in Unicode with a particular numeric value. And then the application is in charge of accepting the character or doing something with it and inserting it possibly and applying all the style and so on. But if I hit control at the same time I type a key, for example, control P, the application will interpret it differently. We'll say, oh, that's my print command. So you can think that this program, this keyboard driver, is connecting the physical computer to your application through a possibly very complicated program in the middle there. Now, physical keyboards generally have 4 rows, but that's not always the case. They can have 4 rows. There can be a numeric keypad. They can have more rows. If you go to Tom Mulaney's talk, you'll hear about the plans that what people have done for Chinese keyboards, which will have amazingly huge racks of characters that were physically selected. But modern physical keyboards only have 47 keys generally, and then you can get different combinations of those, but that leaves you with only a few hundred potential combinations of characters. Is this something that people can remember to type their languages? But also remember that many of these combinations, such as control keys, are not actually used for characters. A virtual keyboard has a lot of things it can do. If you hold a key down, it could repeat it. Or it could say, oh, 3 dots. Well, that's the same as the to be continued character called ellipsis. And the program could be smart enough to say 3 dots means put that as an ellipsis character, which is a separate Unicode may have a separate representation. It's going to be prettier. It's going to be more compact. You can type in key combinations, and an example of typing the copyright can be done if the application is smart enough to represent that as the particular copyright symbol. You can switch layers, of course. Layers can be programmed in. Long press is, of course, a very valuable thing in mobile devices. Why do we have long press? Because the keyboard area is small, and we want to give people the capability of typing characters that they may not need quite so much by holding down longer. I find long press personally quite annoying because I can type fast, but the long press slows me down. But it's absolutely essential for many languages that have more combinations. The virtual keyboards also offer the possibility of other kinds of characters such as emoji, and the general program name for a complicated input method is actually the input method editor. IME is what people often say is a virtual keyboard program. And this is representing the idea that the programming in that green box that I showed you earlier can be quite complicated. It doesn't have to be simple. Here's an example of a language, the Kuhundi alphabet, which we built with the Translation Commons, and they have 6 different options for each of their vowels. So this long press is useful, and it saves space. Is it the best way of doing it? Well, not the only way, but maybe this is a good way for doing it if those keys do not interfere with people typing fast enough. Another way of doing that would be to have 6 separate diacritic marks and type them either before or after the characters. But this was a design decision we worked out with the Kuhundi people, and they found this to be useful. For small character sets, that green box can be pretty small, can be pretty simple. You just can imagine it is like a physical typewriter where you map each character to its position on this, or to a character that appears on the screen, and use the layers as appropriate. And things like Azerty, the French keyboard, QWERTY, the English language keyboard, and some other keyboards for smaller writing systems, this works just fine. But many languages use scripts that are more complicated. Tex showed you the Cherokee writing system. Cherokee writing system was invented about 200 years ago, and it is what's called a syllabary. It's very similar to Indic writing systems in the sense that characters represent syllables, not just individual sounds. And there are 85 characters in the Cherokee syllabary until about 10 years ago when the Cherokee Nation said, we want to have lowercase as well. And so they added 85 more characters. That doesn't fit very nicely on a physical keyboard unless you use the control and shift and all the combinations there, and I can't remember them. Myself, I don't speak Cherokee, and my friends in the Cherokee Nation have said, well, you could do a keyboard like this. This is one layer of the 4 they need to type all the characters, not counting their digits and their punctuation. But my Cherokee friends can't remember this because it's just too darn many things to remember. So they worked with me to develop a phonetic keyboard. They have a character, this first one that looks like a C is called sa. And they have 6 vowels, a, e, o, u, and a. So there's sa, tse, tsi, tso, tsu, sa. So if they want to type sa, that first character, they type TSA. And up comes that first character, not the Transportation Safety Administration, incidentally. Then they type LA for la, and that gives them the second character, which looks like a W. And the gi is the one that looks like the English Y. It's based on English sounds. This works very well for the Cherokee folks because almost everyone in the Cherokee Nation also speaks English. And in fact, they want to make sure that anybody who speaks English has the opportunity to learn Cherokee. How does this work inside? Well, it's called a phonetic input method. The sets of keys are represented in some script, in this case Latin, for example, because people know that well and know the sounds of those. There's a context of the characters which were typed previously. So for single keys, there's a simple rule in the programming language that defines the keyboard. This is a keyman, which is a keyman developer, which is an application that we use to develop keyboards. It says, if you type a T character, output a T. But if you type this S character, it outputs this other symbol. But each single keystroke represents some certain output. But then there are rules. It says if you've got T and this S character, and then you add an A after that, that goes to the sound sa and gives you this character. But if you type the T and the S followed by an E, you get the C character, or say character, and that's a different character. And so there are sets of rules that define all the possible outputs based upon several Latin letters input. The trick is, for anything that has a syllabary like this, is that the sets of rules can be kind of large and complicated, and you have to figure out what would people type. And sometimes it's not intuitive. But when people in the Cherokee Nation type, they prefer this one, at least on their desktops. But there's another possibility as well. The Cherokee folks worked with Apple and also worked with Google to develop in Gboard and iOS a keyboard that is based on a phonetic input, but it's a phonetic input based upon their characters. So in this particular case, you see a set of Cherokee characters. These are, you could think of these as all the consonants. And then at the bottom are the vowels, a, e, I, o, u, a. So if I type the sa character followed by the a, that gives sa. And then after that, it shows me all the possibilities. The keyboard on the soft keyboard device actually changed to show me both the lowercase and the variations with that first TS sound. It lets me type in sa, tse, tsi, tso, tsu in 2 keystrokes rather than 3 keystrokes. So the phonetic input doesn't have to be in the dominant language. It can be in their own writing system. And in fact, for Indic languages such as Tamil and other languages, people are developing keyboards that are based more on sound as rather than a Latin input system. Now, we mentioned these things here. These all have to be represented or made possible when you're designing a keyboard. We have to think about these options. We have to think about these considerations when we're putting together. These are often done as negotiations between Translation Commons developers and the communities. And this is usually done over email because many times we are in time zones literally 12 hours apart. But all these things have to be worked out as we design a keyboard. The other thing that is important to consider is that things like predictive text, which become pretty easy to do on a touch screen, are done simply with the same model. That blue or that green box in the middle, though, is a little more complicated. So instead of just typing in what you, or presenting what you've typed, it also has a lexicon. It knows the words that are common. And if frequencies are available for these in the common use of the, then this can be used to look up and present options. And most of us are familiar with predictive text in English, but this can be done in any language. Oh, I wanted to show you here. There is some predictive text in the Cherokee that is available too, because the Cherokee folks gave us some words. So predictive text in any language can dramatically speed up things. Now, there are some languages that are agglutinative, where they actually build large, complex, what we would call words out of many pieces. Predictive text is a little tricky in languages like Basque and other languages where you have to have a lot of pieces in order to form the single concept. What we would call a word in English is, or what we would call a word is often a whole sentence or a whole thought in agglutinative languages, but these technologies may be applicable in some of those. So Tex, I think this is back to you.
I think we've had a couple of questions.
Oh,
Do you want to read off the questions? We'll take a break for the questions and then,
Sure.
Yeah,
then I'll
so
continue.
First question is from Brian. So for so what do you think what role can speech
Yeah.
recognition play?
I'm sorry.
Okay. In this.
So from Brian, he asks, what role can speech recognition play? I know free from transcriptions will be hard due to the lack of training data, but it should be possible to train an AI to recognize letters, phonemes, and also control phrases. Any thoughts on this?
What was the first part of that question?
Oh, what role can speech recognition play?
Speech recognition.
Yeah, like voice recognition and also.
So it certainly can play a role. I think there are a lot of people use voice recognition these days for the majority languages all the time. So they can certainly play a role. I think somewhere in there, well, I think the answer is it can play a role, and it can either be the only way or it can be supplemented by some keyboarding in order to help with editing or refinement of text. I know when I worked with voice recognition, it may have gotten better, but it can also be rather tedious to work with, you know, depending on what your topics are and so forth. So, and certainly AI is going to increasingly play a role in just about everything. So.
I just want to add, though, for many of these languages, the data on the speech sounds and the representation in words is not available yet. And especially for languages where there may be a few thousand or maybe even only a few hundred people who speak the language, this is going to take a while for that technology to become available. Also, I can type faster than I can speak in many cases, and I can type when I can't speak out loud in an airport or when my wife is watching television or something.
But Craig's point about the data is really important. Some of these languages, some of the oral traditions haven't been developed, so you can go from writing to recovering that, and in some cases it will work the other way, where a language largely transmitted by oral passing on, once there's a writing system and a keyboard for it, you can capture that and then do more study and do things like build dictionaries and so forth. So anyway, was there another question? I thought there was.
So second question from Jennifer. So she's asking either Craig or Tex to talk about the profile of who is usually requesting these keyboards. Are they community leaders or language professionals within the communities? Also, how long does it take to design a keyboard, and how are the keyboards delivered or distributed? Just to the requesters, or is it then available to the public? Thank you. And then they prefer us to use microphones so the online people can hear it better. So is that okay? You guys
Yeah,
use microphones?
sure. They can't hear from what we're saying.
Yeah, I think like that's
Okay,
too light.
go ahead.
Lots of questions there. Many different people ask about or ask us to build keyboards. Sometimes they are
Hold it up.
community.
They want you to hold it.
Oh, sometimes they are community leaders. Sometimes they are people who know the community, who know technology, or who know about us, but the communities don't have much direct access to the internet or technology themselves. Sometimes they are the person in the group who speaks a Western language who can communicate with us. The people in Africa are often talking to us via email in French, but the people for whom they are requesting the keyboard may not be fluent speakers of a Western language. The
Distribution and
and how long to make a keyboard. It can be a few days to a week to build a keyboard using a tool called Keyman Developer, and anybody can use Keyman Developer. It's a cost-free application that runs on any Windows system, so people can build them themselves. If it's a simple set of replacing or putting these characters on these keys without a bunch of rules, this can be done pretty quickly. And when we have built a version, we generally send it to the person who asked us to build it. It's a small file that can be installed on her computer or his computer or his mobile device or her mobile device, and they can try it and give us feedback, tell us what we haven't understood and or implement it quite correctly. I'm also working on one which is for a language, Mende, with a writing system that has about 400 characters. The number of rules in this phonetic input is on the order of 400 to 500, and it is a slow turnaround time just because I have to get it right and then get feedback, and then it's taken several months to put that together. When we do have something that we like, we put it on our website. It's a downloadable file. And in the case of using Keyman, they install the Keyman application. They load this other file that we have put on the Translation Commons website, and that becomes available on their mobile device or their desktop immediately. Did we cover everything?
Yes, I think so. Yeah. So for the last question, you are saying like it's available to everyone, not only the requesters.
Well, if the requester wants us to make it available only to that community, we don't have to post it publicly. But in most cases, people want to share it as widely as possible. If there is a set of words in the language for a lexicon and predictive text, the community might be hesitant about sharing that set of words. So we're listening to the community and what they want to do. But generally, we make it available publicly so people can download it from anywhere. And we charge exactly $0 for doing this work for them. This is an all volunteer effort.
Yeah, the issue of sharing and publishing it is one that's sensitive in each of these communities. So some of them don't want their culture appropriated. They want to have access to the tools and to be able to use the language, but they don't necessarily want other people to adopt it and maybe transform it or and so forth. So that's an issue in the community. Question?
Please use the microphone, please.
How many keywords have you guys built, and what has been the feedback from the communities that have gotten them?
It depends how you count. I built quite a few, on the order of about 15. And then I got Translation Commons people interested in it. And we built a number on the order of 10 to 15 from this in that time. And so we've done quite a few. The feedback has generally been quite good, but feedback from people around the world who don't have good internet connections or good English or Western language skills, sometimes we don't get a lot of feedback. But when we do, it's generally positive. We built a keyboard, Google built a keyboard. This is another example for a writing system called Adlam. It is used for a language called Fufulde. And it is covered, the Fufulde language has several names, but it is used by about 50 to 60 million people along the southern edge of the Sahara Desert. When the writing system was adopted into Unicode, there was no way of typing it. But in 2017 and 18, Google and other companies started building a keyboard for it. And I tracked the usage of the Adlam writing system because they now had keyboards that they could install on mobile devices over those years, and it has exploded in terms of the number of people actually using it for texting, building online videos, and using it as a regular communication. So the use of this in literacy in that particular language and that writing system has been wildly successful. Not because of us, but because of the people who requested it, refined it, and then have explained to people how to use that for preserving their own language and using their language online.
Another point is we also can train people. Working with Keyman and creating rules for developing a keyboard is not that hard, especially if you know how to work with a rules-based language. So in case you're interested and you want to work directly with a community that you advocate for, then come and talk to us, and we're happy to provide some training, show you how to develop a keyboard, and then you can run off and do that. So once the keyboard is available for download, we're working on also distributing the keyboards in other ways. So be able to use a keyboard from one of the Play stores, you know, whether it's Google or some of the others, and to make them available in other ways. So Alex has a question.
Yeah, I have a question. So we have a case, and let's say that you are in the same room with a man who speaks one of indigenous language, and you need to recognize which language is it and to choose the right keyboard for him.
Mhm.
How can we do it?
I'm not sure I have a good answer for that.
Well, so I want to understand. So somebody,
Let's
you,
say,
you have a bunch of keyboards and you want to select the right one for that person, or
yeah, let's say you're a doctor or
Yeah.
registered nurse, and here is a patient, and you need to recognize the language.
right? So we put the language code
Mhm.
and sometimes multiple language codes and the names of the languages. They're associated with the keyboard. And so when you go into Keyman, if it's available, then you
You need
can
to
pull
scroll.
that. You have a
Mhm.
drop down or a list, and you can select the one that makes sense for the
Mhm.
person you're trying to choose one. And that can also be in their native language so they can recognize it.
So it perfectly work if it's a common language, but if it's indigenous, one of 7,000, for example, it's going to be
well, you
very,
just
very
scroll
long
through
list.
the list.
Okay. Okay, thank you.
That's a good question, and it's a complicated question. Almost everyone that we interact with speaks another language, a dominant language. The people in Africa speaking French or English or one of the colonial languages to communicate with us, to ask us for. It's also important to point out that Translation Commons is only one group that does this. Google, in its Gboard product, has over 900 keyboards available for your Android phones. iOS has hundreds of keyboards available also. Some of them from Gboard, some of them that Apple and other people have built. And the Play Store and the App Store have hundreds of keyboards available. So we're not the only ones doing this, but we're one of the few groups that's doing it for indigenous languages. Also, Keyman itself, if you go to keyman.com, you can search in their drop-down menus for the hundreds of keyboards that they've already built for indigenous languages. They work with communities all around the world as well.
And, there are also multiple ways to search. Certainly you want to eventually support a particular language, but you can narrow the list by choosing the script or in some cases by the region of the world. So as you would with other software where you have to select what language does the user want your application in. So,
but the ideal thing would be you could have the person speak to your cell phone, and that person would say something, and that automated system would somehow recognize, this is this particular language. But
we're trying this.
It's a tricky thing.
can you give him the microphone?
Yeah, we're trying to do this, but we found a couple of models, but it's not very accurate.
Who is we, Alex?
My company, yeah, Effective.
Your own company?
Yeah. Uh-huh.
It's a complex problem.
Yeah.
We are not solving that problem ourselves.
Okay, thank you.
Was that it for questions? All right, so we're running a little bit long, so we're coming to the end. And I only have another slide or two. I'm going to tell you a little bit about some futures briefly. One is the creation of the LDML standard. It's a localization data markup language. And that LDML has been around for a while for markup of localization values. But recently we released a version that is a standard way to represent keyboards in this markup language. And so this will enable people who have created keyboards for different platforms or in different ways to include them in CLDR, the Common Locale Data Repository. If you work in localization, everyone's shaking their heads here. They know what CLDR is. Good. So now we will be able to add keyboards into CLDR, which means it will be easier for any of the platforms to say, well, if somebody has put a keyboard into CLDR, I can read it. LDML is XML based. They can import it and make use of it on their platforms and make it easier to distribute keyboards to all of the platforms. And we hope that will increase adoption across technologies. And then we want to look at a few other things. Of course, one of the things is to create awareness. There are several groups who are creating keyboards around the world. We're not all connected to each other or know about each other. And also the indigenous language communities and other minority communities don't also know that this service is available. So we want to make more people aware. And we appreciate your help in spreading the word in case you are working with communities that can use a community. In addition, in order to have improved lexical models and to do predictive text, we want to have a way to collect data or have a repository for data where we can collect words and other language elements in order to be able to create these things, and also is to use them in testing and proof of concept for keyboards. A couple of other things we're interested in is scalability. You know, we know what the possibilities for layouts are. You saw the list of potential options for key presses. There ought to be a way to say, well, given a character set and frequency analysis or some other parameters, generate the keyboard that makes the most sense, right? That could be something that's algorithmic, and to enable us to generate keyboards more easily and for more markets, right? If we're going to catch up with the 3,000 or so more languages that we want to support. And some of that is more automation in the entire process, and maybe we could bring AI into it to help. So those are some thoughts about where we need to go, and a way to make this a more productive process. If you are interested and you want to help and see this grow and support more communities, join us. Translation Commons will welcome you. As I mentioned, we can also provide some training if you're interested in developing keyboards. We also have, if you go to our YouTube channel, we have a lot of information, not only about keyboards, but the other activities and events that Translation Commons provides. We can also use people if you're interested in a particular set of communities and languages. We can use people who can help us with community relations, project management, documentation of our processes. Right now, we're only a few developers, and we tend to spend more time coding than writing and saying, "Here's what I did." Typical for the role. So we can use some help with that. And also, we would like our website and our request forms and the like to be available in other languages. There's a lot of people who speak Spanish or French and other languages that, because our website is mostly English, are not able to be aware. So you can go to our website, translationcommons.org, to get more information about Translation Commons, and also in particular about the keyboard project. And if you have more specific questions or want to volunteer, etc., you can also email Krista at translationcommons.org. And also, if you're aware of communities that might need a keyboard, refer them to us, please. So with that, Craig and I both want to thank you all for your attention. We appreciate those of you who came in person or those of you who watched online. And if there are any other questions, we're happy to take them. Amy? Jim asked something. Give us a second, Jim. Amy's going to read it out to us. Yeah, just read it out. It's okay.
Sorry. So Jimmy asked, Does Translation Commons get involved with defining glyph complements? Glyphs.
Designing glyphs?
Yeah, defining glyph complements. Which guide font developers? Which guide font developers which glyph to add to their fonts to support groups of Latin script writing systems? In British Columbia, I think this will be valuable.
So we have one person in our group who's a font designer. We've been focused more on the keyboard aspects, but if there's a need for fonts, we also, and Jim, you know this, we know lots of font people. We can try and enlist help. And if you have particular needs for British Columbia, be happy to talk to you, Jim.
I have one
Craig wants to add something.
thing to mention. Fonts are wonderful and you can do all sorts of things with them. Is that working here? Fonts are wonderful. The biggest problem with fonts is that you can't install them on your phone. And so even if even when particular fonts are needed by a community, it's a rather frustrating step to get it from on the desktop where they may have been using it for quite a while with the characters they like and the shapes they want, the ligatures and all of the different varieties they want, but then they can't get it on their phones. And installing fonts on phones is almost impossible purposely because it is a security problem potentially. So that's one reason why I originally started working on keyboards themselves rather than the fonts, just because it was a solvable problem. It is an issue, but there are people who are definitely interested in this, and we have folks who are thinking about that. There is a group in British Columbia, First Nations, that has developed about 25 different keyboards for languages of British Columbia and
First Voices.
First Voices. Yes, First Nations is one organization. First Voices is another one. On their website, they have quite a bit of or many different keyboards available for download, and they are built with Keyman. So I hope that helps.
Any other questions?
No questions, but there's a comment from Yu La. So she said, thank you for the presentation. I also work as an endangered, I'm from an indigenous group in the Himalayas, and I'm still designing and also orthography for my language. But once I finish that, I will definitely reach out and develop a keyboard with your guidance. Thank you for the presentation. I also work as endangered language revitalization mentor at ELP. So I will definitely share the valuable resource with my mentees.
And ELP is probably the Endangered Languages Project.
Yes, should be, yeah.
Excellent.
That's great. We look forward to hearing from you.
There are lots of organizations. Two that I know about are Endangered Languages Project, and another one is called Endangered